Warning, if you are listening to this episode, anytime near lunch, you're going to get hungry because we talk about fantastic burger joints, whether that's Rodeo Goat, is that the name of it? Where it has nothing to do with the rodeo or goats.
Hippo
Burger, or Langford Grocery. All
store.
great stops. Somehow between all of that, we managed to fantastically tie it in with our guest Rogelio from NDT on crack detection, where it's going, where it is now, and I think you'll find this to be a super helpful episode.
Burgers and soup.
See, I'm already got food on the mind.
And he said Rogelio properly. So give this guy applause.
Boom! Super helpful episode. Thanks for joining us on today's episode of Pipeline Things. All right, welcome to today's edition of Pipeline Things. We're here on the ppim 23 ARC. We have really been enjoying talking to our technology providers. It's been a lot of fun capturing the energy of the show. I'm your host today, Rhett Dotson, my co-host Christopher De Leon, and we have a special guest again, Mr. Rogelio Guajardo. Did I do a decent job with that?
You did a good job.
Rogelio was okay. I don't know.
Okay, well, you need to do the intro next time. Can we agree on that?
No.
You know,
you got to figure it out.
Chris, people don't know, besides the fact that you give me crap all the time, it's like nonstop.
No, it's
like a nagging work wife.
That's not true. If you remember Trolls where they would poop, it's actually like muffins. That's me. It's like even when it's crap, it's like muffins.
It does not come out as glitter.
It's fantastic.
No, it doesn't.
It is, dude. It is.
It's not.
Great.
But one people think you're kind of a foodie, like a food snob. And,
I'm not a snob. I just like good food.
You are a food snob, but you choose restaurants really well. And
some people would say so.
To our clients, if you ever get the chance to come out with us, Chris generally chooses a pretty good restaurant. So we left PPIM
and it's
the other
not just
day.
it's not just steaks restaurants either.
No, he's good. He's a burger guy. So Chris is a burger guy.
Yeah, I am
so he took us around the corner. We left PPIM. We go to this burger joint.
Rodeo Goat.
Goat.
It's exactly what it's meant. Like they let goats go and you rope them. It's fantastic. Not in the restaurant though.
Actually, none of that happened when we had lunch.
No, it's what it's called, Rodeo Goat.
Yes, but it was a great burger joint. The only challenge is like when you get to a great burger joint, you get this menu and you're like, oh my gosh, do I have this random Star Spangled? What was the Beth burger or something like that? The Jim burger?
No, so their two main burgers were the Beth Dutton and the Rip Wheeler. It was fantastic.
I don't watch Yellowstone. Do you watch Yellowstone?
No.
Apparently that's a Yellowstone
It's
thing.
fantastic.
It hasn't reached Europe.
I stayed away from the Beth burger, by the way. I don't need any more crazy in my life.
The poster, but that was it.
Now that you went on that, so my favorite part of it was something called.
I feel like this is the first time we've had a guest engage us in the segue. He's jumping. This is great.
And it's fantastic. It's called the steaming pile. Going back to giving you crap.
Oh,
and how was the steaming pile? How was the steaming pile?
I don't know if that's going to wreck where I was going with the segue. But the steaming pile, the combination of.
Well, how was it? Not what was it?
It was good.
It was fantastic.
It was really good. So where I was going with that is a lot of times when you end up at a fantastic burger joint, you end up with this menu and you're like, which burger do I choose? I want somebody to help me choose the burger because I don't know if today's the day when I want that fire burger because I have multiple presentations at the end and I need to be competent.
Yeah.
Yes. Or do I just want to go solid with like the standard American cheese? Like, because you can't do that
boring
burger well.
Is what you're saying.
Yeah, but if you can't do that burger well, can you do the other stuff well? Let's be realistic, okay?
Depends on the day, right? It will depend on.
You better be able to do the basic burger well, or this is not going to end good.
If you are a restaurant and you don't make a good burger, just close. I mean, that's the rule.
Wow, it's like that. Have you had a burger while you're in town?
Yeah, of course.
Okay, good.
Yeah, Hippo burgers.
Oh, yeah.
Somebody took you to a good place.
I know.
Somebody with taste.
I know.
Took you to
My colleagues over here took me over there.
Yeah, that's a good one.
Not the first time, but it's a good one.
Yeah, that is a good one.
So if you're wondering, we did not bring Rogelio and NDT on to talk about burgers. We brought them on because let's be real. We chose 6 vendors to do this podcast suite with us. And when it comes to NDT, the reason's clear. When we talk ultrasonics in the realm of pipeline inspection, the name that's out there is NDT. If people want to know what's going on, it's NDT. If people want to know what's happening in the industry or ultrasonics, it's NDT. And so that's why we brought you on. But I think one of the things we've kind of observed, a lot of common questions that we get, is there's not just one crack detection technology. So hence you see where I was going with the burger menu thing, right? There's different burgers
choices
on the menu. But the one we've been hearing a lot about lately, and I would have thought it's new, but apparently it's not new, is the Eclipse technology. And that's what we wanted to chat. That's where we wanted to start the conversation with you.
Yeah, but we
today.
were also strategic, and we'd ask you to introduce yourself because when we look at an ILI system,
I failed.
It's pretty clear, right? It's the tool.
Yep.
Can it navigate back-to-back bins, etc. The sensor package, right? All the architecture around that. The evaluation component, the routines, the algorithm, the software.
I feel like this producer might have told me I didn't introduce the guest properly.
It's okay. The people.
Second string.
And Rogelio, one of the reasons why, there was a bit of a gravity here for you to come on the show is, you're in evaluation, so talk to us a little bit about you.
Tell us,
who's Rogelio?
Where'd you come from? Then we'll get to Eclipse. I did it out of order.
Okay, so pretty much I started in this industry. I had no idea this existed. Pipeline, pigging, nothing. No idea.
Yeah.
So out of university, I got a post that I could go for an interview. I went, I stayed, liked it, and I've been here now for close to 15 years. So I started in Mexico, was there 5 years, and I relocated as a crack analyst. That's my SME.
Yeah.
Then I relocated to Germany to take over the crack analysis globally.
Wow.
And just recently, now I'm taking care of all analysis for NDT Global.
Wow.
In terms of all the different portfolio that we have for metal loss, deformation, INS, crack, all of it at the moment. Yeah.
That's awesome. And actually, I feel like we're very relatable now because I don't think any of us ever intended to be in pipelines or pigging.
Oh, no.
And you know how there's the saying, like, I'm having so much fun, I'm like a pig in a steaming pile. Moving on.
So now that we allowed you to properly introduce yourself, failure is the host. You can mark that one down. And Chris will let me have it, and this producer will let me have it. But again, going back, we do hear a lot about that Eclipse technology.
Yep.
And so I want to start there with you because I think it's unclear for a lot of our end users sometimes where its place fits. So if you can help, tell us a little bit about it. What is Eclipse? How did you guys come about with it? What's special?
Okay, so for that, let's talk first of the natural evolution of the crack technology over the years, right? So we're talking about ultrasonics, shear wave, 45 degree, bouncing in the steel.
Yeah.
If you have a crack, it will bounce back, reflect. That's our standard crack technology. That's what has been out there for 25 years, right? So
does that still run? Or
it still runs.
Okay.
Yeah, it still runs. It's common practice in the industry.
Yeah.
That technology, because of how it's being measured, so it's an amplitude depth sizing. So what's going to happen there is you're going to max out the sensor, how much energy that sensor can get. So that's going to be around the 4 millimeters, so 160 mil.
So this is where the background of the saturation limits and things like that come from, and regulations that have been introduced now is around conventional.
The physical limitation of the sensor itself. So natural progression of that was, okay, what we can do to remove that 4 millimeter, 160 mil threshold. For that, then we have the high resolution tools. So we increased the number of sensors, we doubled it. By doing that, there are additional reflections that are called indirect crack echo that's being recorded. So then there's a second methodology, apart from the pulse echo piece, that you can use to size. And by using that additional one, then you remove that threshold. So now you can go through wool if you want. So the next limitation.
Standard resolution to high resolution, which gives us the ability to break the saturation barrier.
Correct.
Now I'm tracking with you. I'm just repeating it to make sure I'm captured it right.
That's perfect. Now the next variable to address is the geometry of the features. Yes. Not all features are completely radial, like a lack of fusion. You have the hooks in there, right?
Yeah.
So the way pulse echo works is pretty much like if you were playing pool. You're shooting with a 45 degree and you're trying to get a perfect corner echo, getting 90 degree reflection from the feature.
Yes.
But when you have a hook that's like that and 45 degree, it's going to bounce away.
Yeah.
You're not going to get it. So what's going to happen is that the limitation of the pulse echo technology, it's going to detect. So it's really good for detection, 45 degree. You'll detect all of the hooks. The thing is that you're going to undercall them. And that is the problem.
Because of how the energy reflects.
Exactly.
It doesn't all come back.
Because it's pulse echo.
Yep.
Yes.
Gotcha.
So the geometry of the feature will actually be one of those limitations from that technology. So then the next question is, how do we address it?
Yeah.
So it reached a point that if you go out in the industry with a high resolution and you say, well, now I can go through wall, all of that, features are addressed, but pipelines are still failing. Yeah. Why are they still failing? That's the question to ask. So we worked with one operator on this one, where they still saw in their lines that there were additional features going out from NDEs, and they were reporting hooks. And there are studies out there that actually show that if you have a 160 mil feature with a 30-degree tilt angle, could be a hook, but with that 30-degree angle, that feature is going to be undercalled by 120 mil. It's massive, the undercalling.
Yeah, that's big.
And that's because of the pulse echo technology. So then the question is, how can we address it, and how can we keep pipelines safe? So because of this, we embarked in this research with this operator, where we simulated multiple features, and we did freeze breaks. They provided a lot of information for us, and we went out to the market and to the industry to see what other techniques are being used in the ditch, for example, to do this kind of sizing. And that's where we decided to go with pitch and catch. So what we're doing with the pitch and catch is we're using exactly the same number of sensors as in the high resolution tool. So it's a high resolution tool. The only thing is that we rearranged them, and now they're facing each other. So we're doing it's pitch and catch. So we are recording the pulse echo piece, but in addition, the receiving sensor, it's across.
Yes.
So imagine that you have a light, a lantern, and you're pointing towards the wall.
That is definitely not American.
Lantern.
Yeah.
Flashlight.
He could have called it a torch.
How cool
That was
is
the other
that?
thing. He
A torch,
could have
yeah.
called it a torch.
Sorry,
Yeah, I know.
the little
I
difference,
actually
that's
I didn't
awesome.
realize he was talking about a flashlight. I had a lantern
thought
still
a
in mind.
lantern.
I was literally thinking, I was like,
Don't run out of
okay.
oil.
Gotcha. All right.
Okay, well,
Flashlight,
a
lantern, torch, got it.
torch.
Depending on
One
which
of them.
country
You're
you're
just
in.
pointing to a wall. You get all the energy towards the wall, right? But what happens when you put your hand on? Then you get the shade. So that's what the cracks are doing with the pitch and catch technology. So it doesn't matter in this case if the crack is radial, if the crack is tilted, you're still gonna lose the energy from one side to the other.
A couple of interesting things that you pointed to there. You kind of took my next series of questions, because I was going to ask if it was an organic development, but you guys partnered with an operator. The operator approached you with the problem. Then y'all went out into the industry of find solutions, then integrated them onto the tool.
Yep, to see how we could implement that into an ILI tool.
Which is significant, right? Because again, if we were to say this is ultrasonics, and let's go be a bit presumptuous and say it's for a liquid pipeline, it's possible that that wall thickness range is around 281 quarter inch, so 0.25 or 0.281. And if you were having a potential undercall of 120, you're talking 40%. I mean, that's significant.
That's huge, right? So that's why when some of the operators perform the hydro test, that in theory they have addressed all the cracks, they're still bursting
So
because of all of those features.
And it goes back to what you said, right? Rogelio, we're detecting them. But when we look at a specification, it's important for an integrity engineer to recognize there's at least 3 components. We often don't talk about the 4th, which I'll bring up. POD, detection, POI, identifying, POS, probability of sizing, let's be clear. And then the one that we often don't talk about is confidence, right? But we'll leave them out for this call. Or actually, unless you want to bring it up.
No, wait. So let's keep going, because I don't think he's done with the technology. So now I understand. So you got standard resolution, your high resolution, which gave you the ability to break the saturation limit. Pitch and catch added on gave you the ability to size off-axis things, which is the Eclipse technology. But that's not where you guys stop. There's a 4th one on them. There's a new burger on the menu now.
That's Big Brother.
Big Brother. You know what? That's a perfect break.
Rip.
We're actually gonna break right there and hear from Ben and BJ, our sponsors at ppim 23, before we come back and hear about Big Brother NDT. That sounded bad. The Big Brother technology. Thanks.
BJ Lowe here, Clarion Technical Conferences, and if it's February, it must be PPIM. We're here, that's right, for the 35th time in Houston, Texas, starting in 1989, and here we are in 2023 with another record-breaking turnout for the world's largest pipeline technology-related event. We've got almost 3,500 people coming for 4 or 5 days. Almost 200 companies exhibiting on the trade show floor. Another sellout. It's not too early to begin thinking about 2024. We sell out around June or July, so clarion.org is where you go to sign up, and we hope you can join us for the next conference if you're not here this year. Another big part of the conference is our training and education program, which takes place on the Monday and Tuesday of the week. And this year we have 8 really great courses, world-class instructors, and almost 300 people showing up for these specialized courses on different aspects of pipeline integrity technology. I'm here with Ben Stroman, my colleague at Clarion. Hey Ben, what's up?
Hey, doing good. Always happy to be here because it's, as we say, it's PPIM season. It's February. So I would like to remind everybody that we also have a very specialized technical conference that's associated with PPIM. And this year I'm proud to say that we have the largest conference program that we've ever had. It has 94 technical papers that were chosen from a large selection of submissions that were very high quality. So we're very pleased to be putting on these 94 papers during the week. I'd also like to mention that we do have online training if you aren't able to make it to PPIM each year. We present online training throughout the year. You can check more of that out at clarion.org. And we hope to see you in one way or another, online or in person. And if you're not here at the 35th version of PPIM, I hope you're here at the 36th.
Definitely.
All right, we're back with Mr. Rogelio. Did I do all right?
You did great this time.
Okay, that R doesn't always roll quite right.
Did really good.
From NDT, and so right where you left us on the break was the introduction of the Big Brother burger. So we covered, just going back, standard resolution, high resolution, and Eclipse, and the difference between them.
Yep.
The Big Brother is, introduce us?
Yeah, the Big Brother is our phased array technology. All of the others are called monolithic, so we have a physical sensor bolted in the tool. Mm-hmm. With Proton, that's the name of that technology, it's based on phased array. So we could do, if we wanted, whatever the ND technicians are doing in the field. Swiping from 30 degree all the way to 70 degree scanning. We could do it, but then we're going to run at 0.1 meter per second, and that's not feasible, right? So because of that, what we've done is, the advantage of the phased array is that it's allowing us to change the angles depending on the application.
Yes.
With the same mechanical setup. So what we're doing with that is that we're maximizing the output for ERW, flash welds, DSAWs with different widths, heights, and by doing that we are recording 2 full Eclipse data sets with 2 different angles. We're recording high frequency data, which is allowing us to size with the tip, similar to what's being done in the ditch. And we're recording as well what we're calling a high resolution meta-loss shot. That shot is allowing us to measure the weld height, the weld width, if there's misalignment, if there's peaking, all of the above. That's an additional variable in terms of the integrity. All of that data is being recorded eventually down the road.
Lot of data.
So you have a supercar. You have an F1, right?
Yeah.
A Formula One vehicle.
With a giant storage tank.
Yeah.
It's going to have a massive gas tank.
Yeah.
Oh, yes.
And operators know how to drive a Formula One car, right?
Yeah,
I think that's where you come in, Rogelio. I think that's where you have
when
to
we
step
come in. But as an industry, talking about cracks and ultrasonics, the easiest way you can see it is just geometry. Simplify in a cross section. Simplify how the feature looks radially.
Yeah.
Depending on how it looks, you can select out of all of these possibilities which technology would be the best. So if you have knowledge. And
you notice like he's going into the questions, like I'm not even going to ask the questions. I was going to ask how I select which burger off the menu, and you're going right. He's got it. I'm not even needed.
You have to have the right guy. We got the right guy. It sounds like you're complaining.
You're doing a great job,
thanks.
really, but
you
you really
need to just
are.
lay back and let him do his thing. Go, keep going.
You're doing great.
You're tired. You can sleep.
So, okay, I wanted to set the stage for that because I really felt like you were about to go into that. And I loved how you did it because it just wasn't what I was expecting. I had an answer I thought you were about to give and you didn't. So I wanted to pause. How do I choose the burger? And that's what you were about to dive into.
Just get a cross section, of a pipeline, if you have that kind of information or not. Or it's easier way, just draw two parallel lines. That would be your ID and your OD.
Yep.
From that point, just draw how the hook might look, how the crack or the linear indication might look.
Yeah.
So once you do that, if it's fully radial, or let's say radial with a tilt up to 10 degrees, your high resolution technology, not the pitch and catch, high resolution,
applicable.
Your standard, it's applicable. If you want the full wall thickness sizing, then it's the high resolution. Otherwise, you can go to the standard one.
Yeah.
If you start seeing in your line that you have hooks or you have branching cracks underneath the surface, or that feature is not radial, it starts to change direction under the surface, then you need to go to the pitch and catch. Pitch and catch with Eclipse will provide you the same information as the UCX, but with the capability of sizing those features that have change of direction,
which can be significant, which we've talked about, 120 thousandths, right?
Yep, that would be the worst case scenario.
Yeah.
So that's the way you pick it.
So
simplify it. If you get cross sections for metallurgical assessments.
So where does Proton come in? Whenever you need the absolute best of the best?
Proton comes in when you consider the context of where the feature is located. If suddenly you have a flash weld that has a height of 80 mil, 120 mil in the OD and in the ID, well, that's a tricky one.
Gotcha.
So Proton comes in and you start changing the angle so that you can optimize the reflections coming back.
Not just the crack-like features geometry, but the geometry of the environment, i.e. the wall thickness or the seam. So you're able to calibrate the angle in which it's trying to detect, identify, and size.
So Proton will be set up for that specific application. It might be that for pipeline A, you have chosen angles. For pipeline B, you might have another one. And with the same tool, you just change via firmware what you want to retrieve.
Your inspection window.
Exactly. So that one is introducing one additional variable. In this case, it's going to be the context, the geometry, where the.
So it doesn't sound like you're busy that much trying to understand all this. I'm sure the data's got to be easy, right? It's like this is no problem.
It's getting more and more. All of it is based in the pulse echo. Pulse echo is the battle horse for it. Indirect crack echo, pitch and catch, all of that. It's complementary data for the pulse echo. But it does provide improvements in the POI because of this additional signals, and of course the depth sizing tolerances.
So it was actually really helpful how you laid out the framework for selecting the tools, and
maybe not selecting, but rather like a framework for capabilities.
Understanding when and where to use them. What really surprised me is it's not. You really have to understand the threat before you engage the tool. You are best served, let me say this, if you understand the threat you're after before you engage.
We also shouldn't stop there. We also have to think about what is the assessment technique, right? So once you get the data, what is it you're trying to accomplish? Because each of those specifications will give you a different level of assessment. If it's more deterministic, maybe that's one technology. If you're going more probabilistic, maybe there's advantages using a different one, which is why we say the capabilities, right? It really depends on what you're trying to achieve.
Exactly.
And that understanding the threat, what you want to achieve, drives you to select the appropriate tool based on your integrity needs. That's really helpful.
For example, this year you might choose high resolution, and in your 3-year cycle, then you'll choose Eclipse.
Based on what you find in the field. Right?
Exactly.
You went and dug something, you find a big radio, an off radial component to it of greater than 10 degrees. We need to look at something else.
Exactly. Or just as an inspection cycle program, you can be alternating between technology because you're not expecting, because you know your pipeline, right? As an operator, you're not expecting it to grow that much. Then you can start alternating and selecting and building your integrity management program based on the portfolio or technology
that
is out there.
The portfolio of data, looking for change at that point.
Correct. Yep.
That's good.
Yeah.
This is fun.
It is fun. So one of the things I wanted to touch on, because you kind of got me thinking, right, is as you went from using just standard pulse echo to integrating pitch and catch, as you integrate a new technology, how much does your analysis have to change? Because I know it's all ultrasonics, but suddenly you're looking at things from a different perspective. I would assume that the pulse echo data is not the same as the pitch and catch data, and I would assume that somebody that's been doing phased array with different angles, that data perhaps maybe looks different So how much do you guys have to, what's the role and analysis of all that? How have you seen analysis evolve with the different tools?
So our job, we're a service provider, right? Mm-hmm. The tool is just a mean for us to get the data that then is gonna drive actionable things, right? So our analysis team, whenever we have a new data set to review, we need to train them, we need to develop algorithms, visualizations, sizing curves, rules, guidelines for analysis. We need to do the whole lot.
And we still want people for that, right?
Yeah, we're upskilling our team so that they are able to address all of those, for them to be able to provide this recommendation of this pipeline actually needs a specific technology. Because many times when we provide the report, we might be telling the operator, well, next year we recommend you to go with another technology, or you don't need this one, it's an overkill because your pipeline does not have that type of anomalies.
Which also kind of, you're hitting on good points here, Rogelio, right? Because a lot of times in these integrity plans, and I like to go back a little bit, right? If you look at the intent of it, it was always establish a framework in integrity, do a baseline, and then based on what you learn, you adjust.
Continuous improvement.
Right? And so depending on where you are in the life cycle of pipeline A versus pipeline B, you don't always, and again, our marketing teams maybe are not always fond of this, right? You don't always have to go with the F1.
Correct.
Right? First, let's gather some data and understand what I'm dealing with, because
sometimes you can go with NASCAR.
Because, well, we know this. Well, left turn, left turn, left turn, left turn, left turn, right? But the point is, I think what we're getting to is there's finite resources.
There are.
And integrity programs are always trying to budget those the right way. And so I think what you guys are doing is you're giving operators the suite of capabilities that they need to manage the integrity of their system. Right?
Yes.
And throttle where they need to, right? And use the right car for the right task. You know, you don't need the F1 to go down to HEB and pick up a gallon of milk.
Correct.
You know, unless Rhett's there and you want to flex on him a little bit.
No, if Chris drives his truck like it's an F1, no matter where he's going, all the time. I genuinely am afraid for my life sometimes when Christopher drives. I was like, how have you made it? And we're in downtown traffic, and he is bobbing and weaving, and I'm like, and I'm grabbing the handle, the O pile of
the hang on bar.
And he's like, Rhett, I've never been in a wreck. I'm like, God, why would you say that right now while we're doing this? Okay, in the last couple of minutes we have, and this has been fun. I'd like to know a little about where's NDT going from here, right? I assume it's in the end of the line. You guys.
Oh, let's say it this way. What do you want the audience to know?
What do you want the audience to know? But I do have one question. Is it possible to adapt UCD for off-axis cracking greater than 10 degrees? Could you develop tools and partner with operators if you find yourself needing to hunt 30-degree cracks that are off of the pipe axis?
Well, we presented a paper on that today. We had cracks, SECs following the coating disbondment, 30-degree skew, integrating circumferential and actual data to understand it, pushing the technology to the limit of actually both understanding which components of that type of feature might be axial, which one is circumferential, which one is sloping. And
so is that technology redline, since you're pushing it to the limit?
Oh, you're so
we're always pushing it to the limit, because what's happening is that there's many crazy things out there.
There are. That's why I was asking. I know some.
And we're pushing and developing procedures many times for specific applications, extracting from the analysis side and squeezing every ounce of information that we have there that we can provide back. We might not be able to provide a depth accuracy to it, for example, but at least we might be able to provide a qualitative assessment saying, well, ranking based on how the data looks and how the technology works, the physics, that one might be deeper. And we've done that with penetrators.
But I'll go the other way,
Eclipse,
right?
actually.
Even if you don't get to the point of sizing, right, you're still enabling the operator with concepts of like outlier management.
Yes.
Right. So, for example, I've run. Let's talk over the span of. I'm going to pick a random time frame of 10 years. Right. We baselined it with UCX. We found out that we have hook cracks that we need to address. I ran the Eclipse tool, and now it's like, how do I managing my outliers, right? Because typically when there is an incident, it's like, oh, well, there was something very unique about this.
Yeah.
Yep.
Right now, you're even allowing that as a case of like, even if we can't size it, maybe the other tools didn't see this. Now you know about it. You can make a decision.
Data integration is everything here. All data sets that you have, from all different technologies in that asset, or at least that the analyst would have access to, all of that is being leveraged to make that decision. It is required. All the information is there. And understanding the implications from the technical point of view, from the data acquisition of this technology can give me this. And I can push its limits up to this point, and the other technology can give me that. And I'm pushing everything, understanding the technology, then you can derive these processes to actually help a little bit for those features that are the outliers.
So tell you what, this is a good stopping point.
Yep.
I've really enjoyed this. Rogelio, thanks for coming on with us. I understand why you were recommended to us now. The person who recommended us, you shall remain anonymous, but it was a good recommendation. And really, thanks for joining us. This is fun. I will say one thing. If you're into burgers and you're in Houston, you need to find Langford Grocery. Okay. So Langford Grocery was featured on like burgers, dives, and like a show. Total dive when you go into it. They used to only take cash until recently. They started taking credit cards. Fabulous burger and fabulous blackberry cobbler.
It's not a grocery store, for the record.
It's not a grocery store.
No.
I think it used to be a long time ago.
It's not a grocery store.
Like there's the floors are like uneven because the trees growing out of the side of it. Only open for lunch on certain days.
I'll ask my foodie guy at the office because he's normally taking me
Langford
to all
Grocery.
Of this.
I'd say arguably one of the best burgers in Houston.
It is. It is good, but it's up there with Rodeo Goat and Hippo Burger.
Good.
On that note, you've heard a lot about burgers today. I want to thank our guests. Thank you for joining Pipeline Things. If you did not make it out to PPIM 23 this year, you definitely should make it out next year so that you can see these types of technologies, these types of papers, and join us again in 2 weeks on Pipeline Things. I'm your host, Rhett Dotson, my co-host, Christopher De Leon, and our guest, Rogelio from NDT, signing off.